Okay, so this is going to be a video on a summary of section 2, which is the basic concepts of vectors. So I'm going to start off with the vector representation. So there are two ways of doing this. There's diagrammatically and there's via textbook. So starting with diagrammatically, we should know now that we do this using a directed line segment. So what is a directed line segment? Well, it's made up of a line with an arrowhead. And the two parts of that are obviously the line and the arrowhead. So the length of the line symbolizes the magnitude of the vector, and the arrow direction symbolizes the direction of the vector. Fairly straightforward. Next, we have the representation in textbooks. So in a textbook, we can have, well, three different notations. We can have AB with a line on top, and this is where A and B are just 2 points in space. So it could be XY, could be ZX. It's just the 2 points in space where the vector goes from the first part in that AB to the second point. So obviously this goes from point A to point B. The next representation we have is a bold interfaced A, and it's always going to be lowercase, but obviously again the letter doesn't matter. And finally we'll have an underlined A. And we use the underlined A because most of the time when we're writing in an exam or in a book ourselves, we can't write in bold, so we underline it to have the same sort of effect. So another representation we have is the representation of the magnitude. So what we've learned is we symbolize the magnitude of a vector by using modulus signs around our textbook representations. So for example, the magnitude can be symbolized by AB surrounded by the modulus symbol, can be symbolized by a bold interfaced A surrounded by modulus, or finally a underlined lowercase a, again with modulus surrounding it. So that's a summary of the vector representations. Now I'm going to go on to vector ideas, which is the other thing we've covered in this section. So we know that we can have equal vectors or opposite vectors. So vectors are equal when they have the same magnitude and direction. So I've given an example here as 6 centimeters going towards the right, symbolized by vector A, is equal to 6 centimeters, again going to the right, which now is symbolized by B. So vector A is equal to vector B. Opposite vectors, well, these have the same magnitude but opposite directions. So again, vector A is 6 centimeters to the right, whereas vector C is 6 centimeters to the left. So we can write this as vector A is equal to the negative of vector C, or vector C is equal to the negative of vector A. Finally then, we have free vectors. So for both of the above type of vectors, equal and opposite, where they are in space, so where the vectors are in space, does not matter. And what this means is the vectors are known as free vectors. Later on we're going to come across position vectors where their location in space does matter, but for now we just need to think about vectors as being in any position in space.